Hello, everyone. Welcome to the AI and Data Speaker Series. Today, we're joined by Marc Klingen, who's the CEO of Langfuse, which is an open source LLM engineering platform that offers a variety of functions from traces, evals, and prompt management to metrics and debugging. Langfuse is really one of the premier startups in this space. Um, and as many of you know, we actually already use Langfuse quite extensively in Samsara. So we're really excited to have Marc here speaking with us today. A couple other notes about Marc. Langfuse was a startup that he launched with co-founders at Y Combinator in 2022. And even prior to Langfuse, Marc with co-founders had built a variety of LLM agent systems, which kind of informed a lot of the work that eventually went into Langfuse. And then a longer time back, Marc was working with DHL, a Samsara customer, working on problems that were a little closer to Samsara. He also has a master's in computer science from the Technical University of Munich. And I think today you're joining us from Berlin. Is that right, Marc?
That's that's correct. Together with our technical team, we are in Berlin, travel to San Francisco often, and one of my co-founders just moved to work more closely with our enterprise customers in the Bay Area, but generally we spend most time in Berlin.
Excellent. Great. Well, I'm glad to have time with you today, and I'll turn it over to you. I think you're going to start with the presentation. Is that right?
Awesome. Yeah, thanks, Evan, for having me. Hello, everyone. Nice to see some familiar faces from the shared Slack channel. Really enjoy working with you all. And basically, the idea for the session was to share some like high level kind of like concepts that we learned from working with like thousands of teams that went into basically then building Langfuse, both on the kind of like integration side, on the eval side, and then open it up for like a longer Q&A. I already saw some of the questions submitted ahead of the call. Really excited for the Q&A part. And I'll just start my screen to get going. So generally, maybe some like motivation of why is there a need for like a specific kind of like workflow when it comes to LM systems. Like for this session, we'll always talk about the like LM application as kind of a system where often the LM itself is more of a black box or some of the parameters that you can like change. But a lot of it is kind of like application level thinking evaluation that goes into building these applications. So if we just take like a super simple example, I mean, it hasn't changed over the last 2 years, where basically even if you build something like a customer support RAG chat, like the basically hello world of building LM applications. Initially, when you haven't built something like this before, you would assume it's basically a single LM API call. But then even this often ends up with kind of like a chain of different kind of like logic pieces that go into building like a RAG chat for customer support that actually works, where maybe you route to different kinds of like prompts based on the embedding of the initial user question, because you, for example, for password reset or someone having like a billing complaint, you want to give them like a more customized experience. Then when it comes to retrieval, often there are like lots of specific retrieval strategies to optimize finding the best like knowledge documents from your knowledge database. So, for example, like extracting some like metadata query from the user question or context, and then maybe like rephrasing the question to be more specific to the application or domain knowledge, and then running like retrieval against the vector store or some kind of like database. When getting back documents, lots of teams then, for example, like summarize documents ahead of putting them into context to speed up the final generation of the answer, or like to reduce costs. Then we generate something, and before answering to the user, often if it's like end user facing, there's like another like security check with some guardrails just to make sure it's kind of like brand safe and compliant with policies. This is just like a motivating example. I mean, with some of you, I've talked about your use cases. They might not be like plain vanilla like this one, but like similar in complexity, where even like simple things then grow in complexity really quickly. But I mean, these kind of like modular logic then makes them actually work. And there are lots of additional examples like agent state, how context is actually assembled, how to use tools, memory, chat history, like configuration of these security chat checks. And when we like think about more agent systems, I love this post by Anthropic, like building effective agents, where in the end, like viewing agents as basically an LLM that reasons on like a user input and then loops together with the environment via tool calls to get to a final response and before stopping. Like this just shows there's a like looping going on and reasoning and tool calling, which then creates lots of like new problems. I'll dive deeper on like agent evaluation in a bit. But overall, the high level problems that LM like ops basically faces is that all of these steps can be a quality cost and latency bottleneck. Like they somehow need to be evaluated holistically and individually. They include lots of like non-LLM steps. So just focusing in an ML ops sense on the LLM calls is usually not cutting it, because then maybe the retrieval step or the guardrail actually is the like limiting factor to quality, latency, or like cost. Often this needs like hundreds of iterations to go from like initial demo to something that actually can be launched to customers, or then when having launched with customers to take this out of beta and get this from like 80 to the 90 something percent of whatever metric you really want to drive. And it's like a collaborative cross-functional problem where lots of domain experts, PMs, like customer advocates, like many teams are usually involved, and they somehow need to have like a shared understanding. So that's really just like the motivation piece of why even talk about this and why we started working on Langfuse. And our initial basically take was that traces are somehow all you need, because when we got started, we built like GitHub issue to pull request bots back in 2023, where I mean the GPT-3 API wasn't really the best one to then build like multi-file code edits, but we made a lot of like experience on like how to try to optimize this while doing Y Combinator, and realized we want to have some sort of like trace abstraction that we knew from Datadog and Grafana, but then use it in a more data sciencey way to actually iterate on the application. So basically, our initial launch of Langfuse in 2023 was adapting traces and making them useful for the LM Ops workflow, where just as a recap, basically we have spans, which are all of the single steps within an application, which can be LLM calls, but don't have to. And they can then capture like input-output values, timings, can be nested, and include additional metrics such as like streaming latencies, token counts, costs, and error states. And then we can group them in a trace, where usually this is like a single API call, single agent response, which is then like a collection of spans with some attributes. We have like a third concept that's not mentioned here, which is more of like a session, which then groups things in a conversational application, but I'll touch on this later. So this is basically then how it looks like in the latest Langfuse UI, where, for example, for some agent SDKs, we have this graph view that you saw on the bottom left, a timeline to understand how all of these steps then stack. On the right side, more visualization that's very LM specific. So, for example, parsing ChatML or the OpenAI responses API outputs nicely in the UI to make them accessible to team members. So this is just some basic like how we got started with traces as basically the basis. And then over time, over the last now 2.5 years, basically Langfuse grew from tracing, which was initially very production oriented, but some teams also pick it up in development when the system is too complicated and they want to look at something or share something with colleagues, into first online evals to then understand in production what works and what doesn't. I'll touch on this in a bit, like the common workflows around evals, then prompt management to allow teams to iterate collaboratively on prompting, especially in cross-functional teams. Then fourth, more like offline evals, so how to evaluate well in development on top of data sets. Then most recently, we added prompt experiments to iterate on prompts in UI and instantly get feedback, and re-release basically. We basically was a big rewrite of the whole backend logic to make Langfuse truly scalable and scale to like billions of events. Overall, all of this is basically on GitHub. So if you wanna follow us more closely, we post probably like daily or multiple times a week new releases with new capabilities. Quick about us. We are basically a team of 8, mostly in Berlin, Germany. Work with some of the best teams, including, I mean, many of you folks, Twilio, Khan Academy, lots of different use cases, lots of like startups as well as enterprises, and have grown quite nicely on the open source side as well, with over like 4 million SDK installs a month or like 4.6 million Docker pulls. I'm very excited about the adoption because it really drives product development, making the product actually good, because we can generalize and see what people want on aggregate level. So let's dive deeper. I brought 2 topics: one, evaluation, and second, how to integrate something like Langfuse nicely into like an end-to-end workflow to get value. So let's start with evaluation. I really like a flowchart by Evidently on how to continuously improve LM products, because it nicely reflects of the workflow that Langfuse drives, where we have the offline component and the online component, so more development related, and the other more basically in production. So usually teams start with testing data sets that might include like happy paths or some edge cases or some like red teaming. They're basically unit tests on the application, can be for a single step or can be also like on aggregate for the whole system end to end. Then usually teams run experiments on these data sets to iterate on like models, prompts, tools, logic. So anything that could be an idea that you could iterate on to improve results. I think the interesting bit here is coming from more traditional software engineering, where I mean you have some specification, you add tests for the specification, you build it, CI passes, you have a one review, and then afterwards basically it's released, and you only revisit it if you want to refactor, if basically it blows up in production. Here, usually, we have this continuous, more data science, ML ops kind of view on it, where it needs like constant iteration to improve metrics. And like I haven't seen a team yet that just launches something that works right away. So basically, this loop is then really interesting, where in like an offline setting, it's important to nail some sort of like automated evals to get like a very quick feedback loop on an experiment to understand whether it kind of like drove metrics or caused regressions. And this is then like often like a like circular loop of like just adapting some experiments until metrics trend into a nice direction. Once we have like a new increment we can deploy to production, then production we need usually some sort of like guardrail. If it's like a customer facing application for like input output guards, generally we have made the experience that guardrails, like for guardrails, there are lots of like good open source implementations, and they are very different to other evaluations because you want them to be usually contained in the application itself to cut down on any like uptime or latency issues. And usually there are like some like small classifiers that can be used. And within our documentation, we feature like a larger group of different open source packages that can then be also evaluated and monitored via Langfuse. Where basically tracing comes in. So in production, we have user inputs, we use guardrails, we can then use the tracing that I showed you earlier to capture the real data of what's going on in prod, and then run our monitoring efforts on top of this tracing data. So this is about, on the one hand, evaluations, which I'll go deeper on in a bit. Second, like debugging, where many teams, for example, if a user flags that something isn't right, or they just like sample then some traces, like going deep on them to understand where really the kind of like bottleneck is, what to improve. And manual review, many teams use the annotation queues in Langfuse to then, for example, sample out a number of traces and then have people who actually know something about the workflow or domain review them manually to make sure that quality is good. Because in the end, it's all about then adding new test cases, because the core assumption is the test data set is okay, but it will never perfectly mirror what's going on in production, and continuously adding to the test data set is interesting, because if it doesn't reflect the distribution of inputs in production well, then basically what we get out of the evaluation step doesn't really reflect how good the application will run in production. And second, then usually when seeing problems in production, like we try to like fix issues with the application when more of a like being in more of a debugging mode. And then this kind of like offline setup again is extremely relevant to make sure that our fix didn't cause like any new edge cases on things that have worked well before. So yeah, I spent a lot of time on this slide, but generally, like this process seems to be the most important thing to get right when I talk with many of our users, because in the end it drives results, drives time to market of use cases, like cuts down on effort that's spent on maybe like development loops that don't lead to anything. So getting this right for an application is really interesting. Then regarding like evaluation methods, this is basically in this upper right corner of evaluating in like an offline setup, so how to compare an experiment to a test data set, and in an online setup where it's about how to automatically like label and annotate data that we see in prod. We usually see 5 big buckets of evaluation methods, where I mean online and production, it's interesting to gather user feedback. So coming back to the customer support use case, like some sort of like CSAT, or where you ask users whether like a session was good. is usually interesting because if they are unhappy, then it's interesting to like revisit the session. Many teams that we work with were like then extremely successful with like more implicit user feedback. So if there's some sort of like UX that you can add to an application that collects data about whether the output was good or helpful, it's really interesting because then you just have like a lot of signal, and it applies to many of your production traces, where usually user feedback that's explicit like is like lesser in volume. An example for this could be, for example, if the application generates some sort of like response that then agent reviews and can forward to a customer. Like if the text isn't edited a lot, there's like a strong signal that it's probably good. While this is basically then human in the loop without directly asking the user, which is usually really interesting to consider when building applications. Then we have this overlap of things that work online and offline, where it's one manual annotation, so labeling data within Langfuse, or for example, when syncing Langfuse data to something like Labelbox or Label Studio. Most teams want to get to like fully automated evals, but trusting fully automated evals or trusting user feedback is really hard if you don't have experts or domain people who actually understand the domain, review the data, that gives you confidence that user feedback or like automated evals actually measure what they should measure. So we see like the best teams that we work with go really hard on manual annotation and labeling production and development data. Then model-based is everything that's automated and uses some sort of like model or classifier. I think LLM as a judge is usually like beautiful in a way that it generalizes well and it's like a good starting point. But then, for example, for toxicity or some sort of more niche topics, they're just like very good classifiers. For example, in Hugging Face, where using LLM might not be the best decision. And finally, rule-based. So, for example, when including like URLs in a response, it's interesting to just curl each of them to see whether URLs actually work, or check for some sort of like regex if you expect some credit card number or email address in the response, or like deep check whether a JSON is the same as in the development data set. So this is like the full spectrum of things that we see, and usually teams just use a combination of all of them and then correlate. I just want to dig deeper on a couple of examples around specifics for RAG applications, conversational applications, and more agents. Like things that are special about it. So for RAG, usually like this is a simplified, basically flowchart of how many RAG applications look like on a very simple basis. Offline, it's really interesting to build this sort of like retrieval step and have an evaluation basically framework just for retrieval, because usually you have like example inputs and want to make sure that the correct documentation or reference documents are pulled. So this is like a distinct step that's worth to evaluate in its own right. Then it's usually interesting to identify in production more like documentation gaps based on queries. So just see like the overlap of the query and the documentation space. And again, something that can be like analyzed individually is more the like in context use than of the response. So did we hallucinate any kind of like new facts that weren't in the like retrieved context? So just some specifics on the rec side. Conversational is interesting because there we have the complexity of some sort of ongoing conversation with a user, which then includes many different turns, where it's usually like a user message with then like an agent or LM response. And we have the separate steps within that go into producing each message. So it's interesting then to, for example, in Langfuse or other ops tools, to map this to sessions, traces, and spans, which then like map this hierarchy really well, and you can then evaluate them on all the different levels. Usually, like when focusing evaluation efforts, it's interesting to consider whether an application is more transactional or more like longer term conversational. So for example, when building like an online therapist or like some sort of like advisor to a truck driver, maybe the conversation is more open-ended and you don't really have an expectation for the next best message of the LM application. Then it's interesting to go for like conversational level evaluation to then review the whole transcript. Like online, this is more simple. Offline, this is really hard because you then need to simulate the user. We've published like a blog post just on this, which might be interesting. Happy to go deeper on this during the Q&A. If, however, the use case is transactional, so for example, like an onboarding form that needs to be filled out in a conversational style, like conversation, then usually it's really interesting to just build like message by message evaluators in development with some sort of like historical transcript to then check whether the next best question was actually asked by the application, or whatever was basically the next best thing to do according to the standard operating procedure. So yeah, here I think it's interesting to take away whether the application is more longer term conversational like a therapist, or more shorter term like transactional like an onboarding assistant. Finally, when it comes to agents, so the screenshot again from the Anthropic blog post, there are like a couple of new challenges. So when an LLM loops with an environment, it's usually interesting to dig deeper on the reasoning paths to understand what's going on step by step within the agents. Then a lot of the performance comes down to like tool use. If you have like lots of tools, it's interesting to understand whether the right tools were actually discovered within the agent execution. Second, whether the tools were used correctly, because the input schema might not be fully adhered to, which can then lead to problems or additional latency if you need to retry. And costs of tools, because depending on what you use, when it's like external, this might be expensive over time. So it's interesting to apply some sort of like cost function to it as well. If you use something like React, for example, as like an agent like framework, or like a philosophy, then the kind of like planning accuracy, so not just like reasoning during every step, but also the planning ahead, is interesting to evaluate in its own right. And the robustness of like when tools are not available, or if they return some like error states, like how does the agent deal with this? Does it retry? Maybe you build this in application code instead of like let the LM decide whether to retry. So this is usually also interesting to evaluate. As like when adding more agent loops to fulfill common use cases, it's then also interesting to go deeper on latency, because maybe if a use case is very prevalent, it's interesting to, for example, abstract a tool that does all of the steps that are necessary for the single use case in a single tool call, to cut down on latency of some very like high frequency use cases. So it's interesting to monitor latency as well. And in case it's more conversational, like memory is usually really difficult, where if it's like multi-turn ongoing conversation, like what kind of memory about this kind of like context goes into like the LLM call initially, or if you have tools that do LLM calls again, like how much memory and context do they really need? So these are the common challenges here. When looking more at the integration side, so how can Langfuse or like generally LLMs tooling fit into a process that's already established on application that you want to build? Like I want to highlight like a common like architecture overview, where usually we have some sort of like LLM provider or internal like serving layer that the application directly accesses. And then Langfuse comes in for more asynchronous tracing, meaning Langfuse is never in the critical path, and all of our tracing integrations shouldn't add any latency or uptime issues, because all of the events are like buffered in the background. And optionally, you can also use a solution like Langfuse for prompt management. So if you want to like collaboratively edit and version control prompts in UI, more on this in a bit. Then optionally, some teams export all of the raw data from Langfuse again to their data warehouse or data lake for downstream use, because traces are interesting for fine-tuning, evaluation is interesting, maybe to mix it with other kinds of like in-product events, or prompt management is interesting for context, or to surface it in the core application again. Optionally, some teams use an LM gateway as well, which can be either like built in-house or something open source like Light LLM. When is it useful? Usually when like access management to LMs gets difficult in a multi-cloud setup, or when individual contributors should get like access to models, but it's really difficult to provide them with AWS or like Bedrock credentials, so virtual key management, failover between models. So for example, some of the teams using Langfuse want to use Sonnet 3.7 a lot, and rate limits are a problem. So basically failover, like implementing failovers between different cloud providers on a gateway level is interesting, or API translation. So for example, Light LM got quite successful because teams could like hot swap models while everything is translated to the OpenAI API. So these are all good reasons for gateways. We have a blog post on this as well if you're interested, because it comes with trade-offs, obviously, where it introduces like a new kind of like potential source of failures, latency, and needs to be operated internally. But if you use a gateway, it can be interesting to directly like forward LLM logs to a solution like Langfuse, or for example, Light LLM as well allows to use like prompts from prompt management on the gateway level, so the application doesn't need to integrate with Langfuse directly at all because everything is handled by the gateway. I mean, when forwarding logs, obviously it has the limitation of only getting LLM calls, whereas usually you want to get like detailed agent traces, which you can't get from a gateway that just sees LLM calls. I'll now go deeper on three aspects of this. One, the tracing. Second, the prompt management aspect. And third, the exports, because I've found them to be interesting. One, tracing integrations. Generally, there are like four main ways that teams integrate tracing into their workflow. One is via like native SDKs. So for example, we have SDKs for Python and JavaScript, just released one for Java as well, where there's like for example, like an add observe decorator or a low-level SDK, where you can explicitly call Langfuse.trace or .span to then manually create traces within Langfuse. Then we've built a lot of like framework integrations. So when using like LangGraph, CrewAI, Semantic Kernel, I mean, these frameworks do a lot under the hood. I mean, this can be interesting to explore, but it can also be risky if you then in the end don't know anymore what's going on. So we've built like native framework integrations that then directly produce these traces for these framework works. OpenTelemetry is interesting because over the last year, the semantic conventions for generative AI shaped nicely. So now some basically frameworks, as for example Spring AI, are also just using the OpenTelemetry SDK for Java, Go, .NET, are like a very viable option to then log LLM traces and spans to Langfuse. We have documentation on the semantics, and you can also like forward these OpenTelemetry traces from like, for example, like an internal collector that you already operate. And finally, as mentioned earlier, if you use a proxy or gateway, you could consider basically forwarding logs from this proxy and gateway, which is nice if you operate like hundreds of different use cases, because you can then like instantly have full coverage of like basic logging and can then pick up like more tracing incrementally when you have time or when there's like enough motivation to do it. Digging a bit deeper into prompt management, where we launched this now, I think like 1.5 years ago between Christmas and New Year's as like initial iteration, because many users wanted it, even though we as engineers didn't really see the value of moving like prompts from like Git into UI, because we felt like Git is doing great at like version control. But I mean, even for engineers, it's interesting to directly, when making changes, see whether a new prompt version might perform better or worse based on like test data sets directly in UI. So, or more like prompt experiments in UI within Langfuse, or when collaborating in larger teams, it's interesting to decouple like the productionization problems from the prompt engineering problems, because then domain experts, PMs can contribute to the effort really nicely. So what does Langfuse do? It does like prompt versioning, where you can deploy different versions to different deployment labels. So for example, like production, staging, or local environments. It diffs the different prompt versions, allows you to run experiments right in the UI. You can reuse snippets across prompts. So if there's, for example, always the Samsara guidelines prompt snippet that you want to include to, I don't know, for your internal terminology, it's easy to reuse this across different prompts that are managed in Langfuse prompt management. You can use it for A/B testing in production, or to then see metrics for each prompt version. How it works: basically, the application can use our SDKs to call get prompt, which then basically gets the prompt from an SDK level cache, because our like core goal here is to allow for prompt versioning in some sort of content management system, but without adding like latency or like uptime headaches to the application. So basically, the SDKs cache the prompts managed in Langfuse prompt management, and always serve any like stale prompts, so they're immediately available. The Langfuse SDK then revalidates the local versions of the prompts with the API, and then we have additional like memory caching infrastructure on the backend side to make sure that even if this one like a server starts fresh and we need to like fetch the prompt immediately during, for example, startup or when it's first used. So we had some like server-side caching logic added as well during the version 3 release, just to make sure that these are also very snappy. And then optionally, when using prompt management, gets more exciting when you link the prompt versions that are used by the application, again with tracing, because that then allows these metrics by version, so like evaluation scores, cost, latency in production, to see when you make changes to prompts, like what kind of like effects do they really have. And finally, on like a more like sophisticated integration of Langfuse, or when thinking about how to integrate it well in like an enterprise AI platform, it's really interesting to think about like the downstream use cases of the Langfuse data, where we power a couple of use cases really well today, and I'm excited to share a few bits about roadmap of the next weeks already today. Where one, there's been a public API for a very long time that many teams use to ETL data into their own stack or to fetch data in like a production or development scenario. But there are also in-app dashboards which are static today and break down cost, quality, latency by different dimensions. We are currently working on like a query language and query abstraction that allows to then power like customizable dashboards in the UI with lots of templates, because we just see so many different use cases. Maybe you have seen the button in the UI, like a request chart. This was like an initial idea of like, let's see whether people all want the same charts, but we have like a list of, I think, like hundreds of different requested chart types, which made us really like rethink this and go for like customizable dashboards right within the UI. Very glad to have some like strong angel investors on board who have built like dashboarding tooling before, because there are like a lot of like technical complexities in building this, because we don't want to break any dashboards once you've built them. Then third, there's the daily metrics API that you might use today already that gives you like cost time series data, which is helpful for internal reporting or to rate limit users. And what we're currently working on is also like a custom query API. So basically the backend that powers the in-app dashboards that are customizable is then also exposed via API. So I don't know, if you really want, I don't know, the frequency of tool calls by a certain user in a time frame, you'll be able to get it. And I'm very excited about it because I think there are like lots of interesting use cases where currently teams need to load the data into their own data warehouse to make them work, where Langfuse can do this under the hood. Background here is in Langfuse version 3, we switched from Postgres to ClickHouse, which was a huge step, made deploying Langfuse a bit more complicated, but comes with a lot of like scalability advantages, and also now allows us to ship these kinds of like query APIs, which would have been impossible to scale on Postgres with like millions and billions of events. And finally, we just today I saw the like private beta we launched it this week of batch exports to S3 or data warehouses. So if like a project really wants the raw data also in S3 to then load it into BigQuery, Snowflake, or like query it with Iceberg, like we really want to power these kind of like downstream use cases. We work with many platform teams, so this is coming as well. I've seen the beta already, and we'll release it this week. That's it from my side with like a high level overview of some topics I hope you found interesting. If you want to learn more, like one, I would recommend to check out our like GitHub repositories, because there's like a lot of discussions going on, both on like ideas. So langfuse.com/ideas is basically our discussions threads on basically roadmap, where we collaborate with our community on what to build next. Support, which is basically one of the best ways to get support by AI or by maintainers. I mean, next to our shared Slack channel. If you aren't a member yet of the Slack channel, I think different people on the call can add you to it as well. And there are a couple of good resources in case you haven't used Langfuse before, where there's the langfuse.com/watch demo, which is a 10-minute product walkthrough. Basically a 50-minute demo that I recorded once and cut to 10 to make it a bit more time efficient for everyone. Langfuse docs, which is a good overview. And maybe you've seen that I highlighted some good resources throughout this talk. And I highlighted many more on langfuse.com/library, which is basically just a link collection of good resources on how to build LLM applications, how to evaluate them, how to build agents, that we found over the last 2 years and that we want to share with our community as well. Yeah, at this point, thanks again for the invite. Very much looking forward to the Q&A.
Excellent. Thank you, Mark. Thanks for being here. And I know that some people have already submitted questions. We'll get to those, but if you have additional questions that you want to come on screen and ask, you can start by just putting them in the chat, and then I'll bring you on. But one thing, Mark, I'm really interested in kind of a zoomed out sense is how you've built Langfuse over the last few years. For example, you talked about the evolution of Langfuse around traces. And just there's the reality that work with LLMs can make for a kind of a challenging environment, because it's like every week there's something new and it's very dynamic. You have to have a team that's really iterating fast and adapting. I wonder if you could tell us a little bit about how you and your team build.
Yeah. For us, initially, it was super helpful to basically join YC, because we saw from other teams how basically product market fit looks like. We iterated through a couple of different basically initial wedges, where we initially, for example, thought we really need like a proxy that caches to then run testing of LLM applications in CI. to do this really well, but then just realized like time to value for this is way too long, and people want traces to then do custom workflows on top of them or just to debug applications. So I think for us, like getting this initial starting point right was extremely important. And once we saw basically Langfuse tracing scale, we knew we are like onto something. And from there, then, I mean, this was just me and my two co-founders. So like a team of 3 can really like adapt quickly to customer requirements and work closely with, I think it was like 5 to 10 YC startups that just gave like a lot of feedback of what they really need and how they use the product. What made us excited was they used Langfuse for hours each day. So lots of activity in product, which is a good signal of there's something. And from there onwards, like launching Langfuse open source is a big advantage because in the end, requirements change a lot. The market is moving quickly, and just having like a big community that shares the excitement of the product, but also like is very direct with feedback and what doesn't work and what they really want to see working in the product helps a lot. Because maybe, I mean, you see here on the screenshot, there's like usually on the things that are requested, sometimes like 30, 40 like upvotes, where it's like a good way to then ask follow-up questions about these requirements, to really talk to the teams that want, for example, like I don't know, subscribing to Langfuse events via webhooks to really make sure that the spec nails the demand of like a large chunk of users. Really like to work with our community. And then I think we have like 800 different mutual Slack channels with like different teams that just really help to work with some partners more closely like you guys. So yeah, this is kind of like how we collect feedback. And then more on the team side, we try to hire mostly like ex-founders or people who can work in more of a like product engineering role, meaning directly talking with customers. I mean, we build a developer tool, so all engineers should be able to talk with customers directly and understand their requests. And then excited to be like launching this end to end, including documentation, handling bugs, handling production issues. So yeah, it's like a small team, but the setup works really well for us.
That's really exciting and inspiring. We talked before about your approach, and then you've mentioned several times open source is really core to Langfuse and your technology. I wonder if you could say more about that. How do you build with an open source approach?
Yep. I mean, it's kind of like a twofold answer. One is why even open sourcing Langfuse, and second, how can you make this a business? Because I mean, everyone is interested in this being around for a long time. In the end, we drive most of the development, and we kind of, I mean, we raised some money from good investors, and now want to scale this as a company as well, obviously. So one, why did we open source Langfuse initially? Was basically we saw the value in the data that's collected by Langfuse. And when talking, especially to platform teams, they acknowledge that this is like very core to their like processes then when they adopt a tool like Langfuse, because they want to fine tune on the data. They want to export it to the data lake. Like a lot of things integrate with Langfuse, or when using it for prompt management, becomes extremely sticky also within a workflow of a larger team. So for us, it just felt right to have this open source where then all of the basically API bound features are fully MIT licensed. Also with Langfuse, basically, if you deploy the stack, the version 3 stack, this is like exactly the backend that also like powers Langfuse Cloud at like billions of events. So no like kneecapped trial version that you run, but actually the real deal. So it just felt right for us. And also we kind of acknowledge that we think over time the tracing aspects of it are quite a commodity, and it will be quite competitive. So we felt like open sourcing it and then building on top and building nice use cases around it is really interesting. How we then like work more deeply with customers is basically when self-hosting, we have some like in-UI features that go beyond the API level or beyond tracing. So for example, like when using prompt management is fully MIT licensed, if you directly want to see like feedback in the UI of whether a new prompt version performs better on a data set, this is basically like commercially licensed, while you can run custom experiments that I showed in the flowchart earlier. You can run these fully open source with our SDKs. So we have like some in UI workflows, or when annotating data or later labeling data, you can use like labeling on single traces in open source. And we have some like queuing tooling around like managing this workflow and assigning reviewers, which is then commercial. And finally, we work with some of like the like very, very large enterprises that then have like hundreds of use cases, where usually it's less about like giving people features, but more about taking them away from some people to make the process compliant and work well in large organizations. So we have like an enterprise tier, which then has some like more of these security workflow approval features. So that's like our stance generally on the whole thing. And for us, the open source community is extremely important, and we have like thousands of teams who self-host Langfuse without any kind of like direct relationship with us that are successful in like very large organizations, which is extremely exciting for us.
Great. Yeah, the open source has certainly facilitated our adoption as well. Well, we're getting some questions. I'll cut over to that in a minute, but I did want to talk a little bit more about agents. I mean, you focused on agents in your presentation, and the many integrations with these agent frameworks that are popping up. I wonder, could you tell us a little bit about what you see around agentic frameworks? And there's such diversity right now, and do you see that they're diverging even further? Do you see that the need for evals is going to become increasingly complex with these agent frameworks? What do you see at this point?
Yeah. Yeah, it's really interesting. I think within our user base, we see like a divergence where the one side is building their own abstractions and like follows, for example, like what Anthropic wrote in their blog post about building effective agents of. In the end, agent is just like calling a model in a loop with some sort of like context and providing it tools. So basically assuming that this is kind of like a simple setup, which works well in some use cases, but then some other use cases is more about like putting basically then the LLM or the model reasoning into like more confined boxes and chaining them. So for example, like small agents or LangGraph are like interesting abstractions where then basically like you can switch states or call some like more tighter abstractions with a tool call. Um, for me, I think it comes down to like how broad the kind of like use case spaces of the agent. Because in the end, if you just have like 10 calls that should be called, then probably there's like a good shot at just taking like a single model in a loop with these 10 tools because it will figure it out. And you can maybe dynamically insert some kind of like standard operating procedures into the prompt or the context, depending on some sort of like embedding of the request, and then should be doing all right. If the context is more complicated and you have lots of different kind of use case types, and for example, I don't know, you want to do a password reset, then maybe making sure that this is like a sub agent which has its own testing suite, its own prompting logic, where you just know whenever an initial router routes to the password reset agent, you just know that this thing is safe and works. So basically, whether to modularize or whether to just build like one agent, I think comes down to preferences and risk and how the variety of use cases. The agent frameworks, like Yannick from our team just wrote like a blog post comparing the different agent frameworks. I also had like a great discussion with Yang Yong from your team about this. In the end, comes down to preference and what you want to get out of the framework again, because some do extremely well on like concurrency, parallelism, basically rebuilding like a temporal IO within the framework to do these kind of like failovers or routings well, and others are more about like pulling for example, from a community. So, for example, small agents became really popular because they have a large community of examples on Hugging Face. Yeah, I think it makes a lot of sense to look into these frameworks, but then like ask, why am I even considering it? Can be memory management, can be routing, or can be that, for example, if you use LangGraph, you get like a really, really nice graph view with the Langfuse. We're currently looking into like expanding this and making this generalizable. But yeah, some frameworks come with like nice developer tooling.